This is Mr. Alexander, and this is the third and hopefully final video covering the Unit 1 test review. We left off on problem number 22, which is in video 2, which is where we're going to pick up here in video 3. So I'm going to zoom in on that. Graph y is greater than or equal to absolute value of x plus 3 minus 2. So from 0, 0, this thing is going left 3 and down 2. So I'm going to start there. I'm going to go left 1, 2, 3 and down 1, 2, and I'm going to put a dot right there at negative 3, 2. And from here I'm looking at the equation, and there's no number in front there, so there's no vertical stretch or compression. So I'm just going to simply go up 1 over 1, up 1 over 1, up 1 over 1 in both directions. And at this point I need to decide two things. Is it a solid or a dashed line? And is it shaded above or below? Now I'm looking at this inequality to answer both those questions. Since it is greater than or equal to, it is a solid line. If it was simply greater than, it would be a dashed line. But since it's greater than or equal to, that's a solid line. For the shading, since it says y is greater than means shade above, less than means shade below. So I'm going to shade all this stuff above here. Just like that. Number 23. Write an inequality for the graph. Okay, well, there's a few things we need to do here. If I'm looking at it, looks like it's been pushed from 0, 0 to the right 3 and down 1. Yeah, 1. And let's look at the slope too. It's definitely not a reflection. Looks like this thing is going up 1 over 1, up 1 over 1, up 1 over 1. So there's no vertical shift, no vertical stretch, no vertical compression, nothing like that. So the equation is going to be y something. I'll deal with the inequality in a moment. No negative, no number. X, if it's right 3, it's going to be minus 3. And down 1 is minus 1. Like that. So to make the decision about the inequality, I see it's a dot. It's not a dashed line. It's a solid line. So I know it's going to be less than or greater than or equal to. So I know I put the equal to there. Now the question is it less than or greater than? It looks like it's shaded below. Shaded below means less than. Y is less than or equal to absolute value of x minus 3 minus 1. Let's graph another one. Number 24. Graph the inequality. Y is greater than or equal to 5 absolute value of x. It's still at 0, 0. But this thing is going up 5 over 1, because that's what that 5 says. It means go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 over 1. And it's going to be a solid line because it's greater than or equal to. And it's going to be shaded above because its y is greater than or equal to. So inside the V shape. Okay. Number 25. Graph negative absolute value of x minus 1 is greater than y minus 5. Well, the first step is always to get that y by itself. So I'm going to go ahead and add that 5 to the other side. And I'm going to put the y first. Notice the direction of this sign, though. Since it says y is less than, I'm going to keep it as y is less than. So that's okay. This says y is less than, this says y is less than. So since I moved the y to the other side, I went ahead and flipped the sign. Just follow the point. If it's pointing at the y, it needs to still be pointing at the y. I'm going to add 5 to get negative absolute value of x minus 1 plus 5. Now, I didn't have to flip the inequality again because I didn't multiply or divide by a negative. If you multiply or divide by a negative, flip that inequality. I simply flipped it because I moved the y from the right side to the left side. Okay, we're going to graph this thing. We're going to start by going right 1 and up 5 from 0, 0. Right one, up 1, 2, 3, 4, 5. And I'm seeing that negative, which means it's a reflection, which means it's facing downward, which means I need to go down 1 over 1 in both directions a whole bunch of times. Down 1 over 1, down 1 over 1. Now, before I draw on the line, I need to decide if it's a solid line or a dashed line. This is a dashed line because it's just y is less than. It does not say y is less than or equal to. It's definitely a dashed line. And because it says y is less than, it means I need to shade below. So it's all this stuff. All this stuff. Okay. Number 26. Solve the given equation. Check your solution. When you're solving these, the first question you need to ask yourself is the absolute value bar. Is there anything on the outside of that? The answer is no. If the answer is no, go ahead and split it into two equations. n minus 1 equals 23 and m minus 1 equals negative 23. And to solve both of these, we just add 1. Doop, 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 doop. That gives me, in both cases, m equals something. 23 plus 1 is 24, so m equals 24. Negative 23 plus 1 is negative 22, so m equals negative 22. Those are the two solutions. 27. Solve again. Now on this one, the bars are not by themselves, so before I can do anything, I need to divide both sides by 20. Absolute value of 2s plus 5 equals 24 over 20. That reduces to 6 over 5. Or if you prefer, that's just 1.2. So at this point, the bars are by themselves, so go ahead and split it into two equations. And the two equations we're going to make are 2s plus 5 equals 1.2 and 2s plus 5 equals negative 1.2. We're going to solve both of those. All right, subtract by 5 to get 2s equals, let's see, 1.2 minus 5 is negative 3.8. Then divide by 2 to get s equals negative 1.9. That's one of the two solutions. And the other one, we're going to subtract 5 to get 2s equals, let's see, negative 1.2 minus 5 is negative 6.2. Divide by 2 on both sides to get s equals negative 3.1, which is the other solution. Okay? 28. Absolute value of 3x plus 5 equals 8. Find all values of x which make this equation 2, meaning solve. These bars are by themselves, so I can split this into two equations. 3x plus 5 equals 8. 3x plus 5 equals negative 8. And so we'll subtract 5 from both sides to get 3x equals 3. Divide by 3 to get x equals 1. It's one of the two solutions. And then subtract 5 to get 3x equals negative 13. And then that, when you divide by 3, that is x equals negative 13 over 3, which we cannot reduce. So that's the other solution. Okay. Moving on to number 29. It's another solving problem. Absolute value of 2x minus 11 equals 3. Find all the values of x which make this equation true. There's nothing on the outside of those bars, so go ahead and split it into two equations. 2x minus 11 equals 3, and 2x minus 11 equals negative 3. Add 11 to both sides to get 2x equals 14. Divide by 2 to get x equals 7. There's one of those answers. Add 11 to both sides to get 2x equals 8. Divide by 2 to get x equals 4. There's your other solution. 29. Moving on to the last page. Number 30. Find all the values of x which make it true. Nothing on the outside of the bars again. So 2 minus 2x equals 14. 2 minus 2x equals negative 14. Subtract 2 to get negative 2x equals 12. Divide by negative 2 to get x equals negative 6. Solution number 1. Subtract 2 to get negative 2x equals negative 16. Divide by negative 2 to get x equals 8. There's your other solution. Here's another one. 2, absolute value of x plus 3 equals 12. Find all the values of x which make this one true. Well, here there's a 2 on the outside of the bars, so before we drop it into two equations, I'm going to divide by 2 on both sides to get absolute value of x plus 3 equals 6. So I just divided the 2 on both sides. And now I can split it into two equations. X plus 3 equals 6. X plus 3 equals negative 6. And at this point, it's pretty simple algebra. Subtract 3 to get x equals 3, comma, negative 9. 32. Same thing, but now we have a 9 on the outside, so I'm going to divide both sides by 9 to get x minus 3, absolute value of x minus 3 equals 1. Just divide both sides by 9, and the reason I did that is because those bars weren't by themselves. And at this point, we've got x minus 3 equals 1, and x minus 3 equals negative 1. So when you add 3 to both those equations, you get x equals 4, comma, 2. Those are your two solutions. On this one, same issue. We've got a 1/3 on the outside, and the easiest way to get rid of that 1/3 is to multiply by the reciprocal, which is 3 over 1, or if you prefer, 3. So I'm going to multiply both sides by 3 to cancel out that 1/3, which gives me the absolute value of x plus 8 equals 18. And now I can split into two equations. X plus 8 equals 18, and x plus 8 equals negative 18. Subtract 8 to get x equals 10, comma, negative 18 minus 8 is negative 26. There's your two solutions. 34. Same type of problem. Got a 1/9 on the outside. I want to get rid of all the stuff on the outside, so the opposite of, or sorry, the reciprocal of 1/9 is 9 over 1, or just 9 if you prefer. So I'm going to multiply by 9 on both sides, which gives me the absolute value of x minus 7 equals, let's see, 7 times 9, that's 63. Break it into two equations. X minus 7 equals 63, and x minus 7 equals negative 63. Add 7 to both of those, you've got x equals 70, comma, x equals negative 56. Check it on the calculator. Okay. Next one's kind of tricky. Same idea though. Now we've got an inequality, but the bars are still by themselves. So we can, instead of breaking it into two equations, we can break it into two inequalities. X minus 5 is greater than or equal to 4, and x minus 5 is greater than or equal to negative 4. We are simply going to solve these. So x is greater than or equal to 9. It's one of the two solutions. And x is greater than or equal to 1. And one thing I forgot, since we multiplied this one by negative 4, we actually, whenever you multiply or divide by a negative, you've got to flip the sign. So this is actually x is less than or equal to 1. Don't forget that with inequalities. Whenever you multiply or divide by a negative, which I did here, I multiplied by negative 1, you got to flip that sign. Okay, last one. What is the solution set? Bars aren't by themselves, so divide by 2 on both sides. 4 minus 1/6 x, absolute value equals 7. And I ran out of time, so I used some movie magic, and I just put the solution up here for you. Here it is. Thanks for watching. Good luck on the test.